Hey you, I meant you, humanity. Do you remember me? It's me, the only ozone layer you have. I know we had bad times. You and your extensive usage of CFCs and Halons and me getting depleted and threatening your health are wild 70s and 80s, weren't they? But after all, we have found back together on 6th of September 1987, right? I can remember as it was yesterday. I mean, you wrote down your promises in Montreal Protocol to treat me better and to ban CFCs and Halons in the future. Later, in the following decades, you added even almost all other ozone-depleting substances. That was all I ever wanted. But nowadays, it feels like you don't care about me anymore.
The ozone layer. In the stratosphere, approximately in 10 to 50 kilometers altitude above the Earth's surface, a veil of ozone protects many forms of life from UV radiation emitted by the sun. Ozone has the ability to completely absorb lethal UVC radiation and most of the wavelengths of harmful UVB radiation. Stratospheric ozone is the only protection against middle ultraviolet light. Ozone layer depletion does not only affect human health, as UVB radiation can cause DNA damage and skin cancers. UVB radiation also affects the physiological and developmental processes of plants and marine ecosystems.
Stratospheric ozone concentration shows seasonality. On average, observed ozone depletion typically begins at the start of August, peaks at the end of September, and subsides by the end of the year. As you can see in this chart, there are three main periods for ozone layer concentration. 1980 to 1988, known as the beginning of ozone depletion. 1999 to 2008 shows the peak of ozone depletion, and finally 2009 to 2018 is defined as the beginning of ozone recovery. Despite this, just recently in 2018 and 2021, large ozone depletion was detected and has been exceeded by record-sized ozone holes in 2015 and 2020.
However, 2015 was caused by strong volcanic eruption, and the strong ozone loss in 2020 was just a seasonal coincidence caused by a strong and long-lived Arctic polar vortex. But there are other potential dangers for the ozone layer that need to be considered. Nitrous oxide is expected as a primary driver of ozone depletion in 21st century. Anthropogenic emission of nitrous oxide, primarily affected by the extensive use of fertilizer, could diminish the gains of Montreal Protocol. Compared to all other ozone-depleting substances, the emission of nitrous oxide is the greatest, but is still not yet classified as an ozone-depleting substance. And due to the rising stratospheric concentration, with a lifetime of around 120 years and the ability to absorb infrared radiation, nitrous oxide is the third most important long-lived greenhouse gas after methane and CO2. These greenhouse gases have the ability to possibly enhance another ozone-depleting effect in addition, the climate change. Stratospheric cooldown caused by higher GHG concentration has opposing effect in upper and lower stratosphere. Depletion will both increase and decrease. The complexity of the interaction between physical, dynamical and chemical processes leaves behind several uncertainties in the prediction of future developments of the stratospheric ozone layer. Surprising reactions or dynamics cannot be excluded.
Don't forget that it's only me protecting you from blindness and skin cancer.